In this video, we'll generate the inverse hyperbolic cosine, its logarithmic equivalent, and its Taylor-Maclaurin series sum expansion. We begin with the dataset of inverse hyperbolic cosine. So array formula. ACOSH, so inverse hyperbolic cosine from 1 to 10. And we'll chart this. Insert chart. And we use scatter chart. Row 1 as header. And for the series, show the trend line. The type, polynomial. The degree, tenths. For the label, use the equation. So here's our trend line and polynomial. Next, we continue with the expansion. So this will be equal to, or the logarithmic equivalent. So array formula. ln of the x values. And enter. And we show the trend line. Edit chart. The series, the trend line, the type, polynomial, the degree, 10th degree, and for the label, use the equation. And for the legend, we show this at the left. So here we have the trend line and polynomial. And we modify this. So this now becomes, that's 1 plus square root of x. So plus the square root of x squared. X raised to the power 2. And we continue. That's minus 1. Minus 1. Now they're all the same trend line. Their polynomials are the same. Next, we continue with the expansion, which is ln 2x plus the summation of a times x raised to the power negative 2n, where the value of n is from 1 to infinity. And the value of a, the coefficient, is equal to array formula, minus 1 times this factorial 2n minus 1. So factorial 2 times n minus 1. We have just completed the numerator. We continue with the denominator. So divided by, our denominator is double factorial 2n. So fact double. 2 times n. And this is raised to the power 2. That's fact double 2n squared. Now we can complete the expansion. So array formula, series sum. Now this is x to the power negative 2n. So that means 1 over x raised to the power 2n, where 2n starts from 1 incremented by 2. That's 2n. And the coefficient will be this range. Enter. And we show the trend line, polynomial. So this is series, trend line, polynomial to the 10th degree. And for the label, use the equation. So here's the equation. And we factor in ln plus 2x. So this is plus, that's plus ln 2 times x. And enter. Their values are almost the same. This is a good approximation because the trend lines are collinear and their polynomials are almost the same. So we have negative 0.604 and this is 0.423, and this is 11.15, also 11.5, and this is 8.01x. For x squared minus 8.1, and it's minus 5.36. For x cubed, it's 3.33, it's 2.16. If we increase the interval to, let's say we increase this to 5, now we have a maximum of 37. Their values are almost the same. So their values are not 1.51. They're for bigger numbers, they're exactly the same. But for smaller numbers, smaller range from 1 to 10, you will find some errors. This completes the use of the Taylor-Maclaurin series sum, the logarithm, and to show the trend line and polynomial of inverse hyperbolic cosine.